And Ali, it's all your show.
Cool. So hi everyone. I'm going to talk about Volta, virtual OLT hardware abstraction agent or layer, whatever you want to call it. It's also has a name, which is vanilla, which is like virtual. Okay.
Speak loud now.
I'm trying. Which is a more generic name for all hardware, for all access hardware. We kind of settled on Volta for now, because when you Google search Volta, you find Volta. When you Google search vanilla, you find not Volta. So we figured that's better. So first, I'm going to start with a motivation. So what is Volta? Volta is a layer of abstraction on top of legacy or next generation access equipment. So initially it's designed for PON, so GPON, EPON, NGPON2, XGS-PON, whatever, XPON, I guess, or whatever, any type of PON. Ultimately, the idea would be to have it scale, have it control different types of access equipment, DOCSIS, DSL, GFAST, even Ethernet devices, even your fabric switches right there, rather than having them with DPA to move to something like Volta. And there are reasons why you would want to do that, and we'll get into them in this talk. But the idea is like if you have, the basic idea is if you have a common management and control framework across all of your devices, and the abstraction is the same no matter what the device is, you're in a better place to write higher orders of abstraction. Okay? So if it doesn't change across all of these systems, every time you move to a new platform, you have to change your abstraction, you're in a bad place.
The question is, there's always a sort of chance to use something like, virtualization and sort of using an abstraction, right? So virtualization is often a lousy abstraction because it's dictated by hardware or protocols. And so, do you think this is the right layer of abstraction versus, it seems that you're going to need drivers to talk to the actual devices. Is there an advantage to having those guys have an open flow?
The devices themselves?
Yeah.
Well, so we'll get and Volta plays that role, can play that role, doesn't have to, but can. So we'll get into that, and we'll talk about it in a bit. So the key value add of Volta is really a network as a switch. Okay, so you make all your access equipment look like an abstract programmable switch. Okay, so whether you have a PON network, a DSL network, a DOCSIS network, it all looks like, to your SDN controller, it all looks like a switch with a bunch of ports on it, and you just go ahead and program it. So another thing is,
all you have is an ONOS hammer. This is an SDN nail.
Yeah, right. This looks like a switch. I will do my switch thing. Right. It allows an evolution to virtualization. So it works well with virtualized devices. Volta can run on the device as well as on a general purpose compute node or in a cloud. Doesn't matter where you run it. If you want to run it on a device, that's fine. If you want to run it in the cloud and have it reach out to the device, that's fine too. It's designed for that. It's got a unified OEM abstraction, like I was saying earlier. It provides a unified vendor-agnostic interface for control and management. So whichever the device is. So right now we have support for various types of PON, but northbound of Volta, they all look the same. They are all controlled in the same way. They all talk. You talk to Volta in the same way, and the translation is done for you. Actually, that translation isn't very complicated, but we'll talk about that. And at least in this context, or in the context of telecommunications, it's a DevOps bridge to modernization. It brings the latest development techniques to the telecommunications world. Something that doesn't happen right now. Right? People still build big systems for telecoms and claim that they are the new stuff when they are actually technologies from 10 years ago. Orchestration, administration, management, I can't remember. management.
Not orchestration, operation and
Operation management, thank you.
orchestration didn't exist when O&M was.
Yeah,
Administration,
yeah.
or administration or automation?
And management.
Oh, and so alarms aren't really usually part of OpenFlow.
No, so we'll get to that.
Okay, okay.
So we'll get to, this is like, these are 2 slides of like marketing, right? We'll get to the actual, like, the nitty-gritty of what you do with alarms. So why did we build Volta? So the reality is that access networks and access devices are just controlled in kind of a chaotic way, right? So when you buy equipment for some vendor, you have to buy their MMS, they have to buy their own solution. It gets worse. Each vendor has its own interpretation of the same standard. So you get different implementations, right? Like everybody is, I don't know if everybody has, but like maybe a lot of you here have seen that if you take 2, say, routers from 2 competing vendors and try to make them talk over a protocol that's standardized, it usually doesn't work, right? Which is insane, right? It's like taking a plug from the wall, plugging it into another plug, and it doesn't work. It's crazy. Right? So ideally, all vendors would have kind of like converged to the same interfaces and would be interoperable. But that's clearly not happening for many, many reasons.
This is for access networks. There's presumably IP networks plugged together, otherwise the internet.
So at the IP layer, they plug together.
Yeah.
But if you're trying to do something like, say, VRRP between a Cisco switch and a Juniper switch, probably won't work. Probably. Not saying it will or won't, but I'm saying most likely you'll have some problems. Same thing for OSPF, same thing for stuff like that. So Volta, in the meantime, kind of provides the first step in that direction. It tries to hide all the differences and the complexity of an access network away from the OSS layer, right? Whether that's your SDN controller or a higher orchestration layer. So feel free to ask questions, especially in the next few slides. I don't have a whole bunch of slides. I have mostly like a lot of time I'm going to talk around. So feel free to interrupt me at any time.
So I have a quick question here. So whatever set of features Volta has, but if the OLT already provides those services, like Qumran or Calyx OLT, so do we have to go ahead and explicitly disable those services so that Volta can?
So you're saying, let me understand. So you're saying you have an OLT that provides what? Netcom?
Pawn management aspect of
Pawn management.
OLT.
I don't know. If it does, I don't think you'd find pawn management implemented on the OLT. It's implemented above, right? But it uses whatever interfaces to the device, which is usually proprietary. So what you're saying is, the real question is, if my OLT and my set of ONUs implement, say, IGMP snooping, should I disable that and let Volta take care of it? The answer is probably yes. Right? The reason being is that you can introduce much more fine-grained logic in a place like ONOS, right? Because Volta is not going to do anything in the IGMP world. It's not going to snoop. It's not going to add any intelligence. But it's going to provide ONOS with an IGMP packet and let it do this stuff. So if you want to whitelist, for example, if you want to whitelist channels, right? And I'm interested in 3 channels, I can whitelist that easily at ONOS rather than pushing that configuration to the device. The device doesn't have that horsepower to be able to maintain in memory whitelist per subscriber, unless you have a bunch of RAM in your devices, and that means the OLTs will start costing a lot of money, which you don't want. Right? The whole idea is to reduce the functionality on that device so that you can pull it out somewhere else. That software layer, software is easy to change. Hardware is hard to change. If I can shift that balance and make the software push all changes to software and hardware, I can either swap out because it's the same management interface anyway. Right? I'm winning, and I can, as an operator, I can change vendor, much more flexibly and not be tied to one vendor.
Yeah, but they don't know that. They are designing OLT without knowing that there will be a software component like Volta to
mean, like some vendors are doing that?
Some,
Their problem.
yeah, I think it's to a certain extent.
Yeah, I mean, that's okay. I mean, you're always going to get vendors who are going to stick and hold on to the old world. That's fine. All right. So,
And you would be on configuration and stuff, like, I mean, the mess and all the, standard stuff and all CR69 standard and CLI and standard.
CLI is not a standard. CLI is using crap.
Everyone's using it.
Yeah, but it's still not a standard.
So what else are you talking about? Like, what else can you expect to access because software download or?
I mean, manage and control your device. Okay? So whatever you do to provision your device, and every vendor is going to sell you their solution and their interface, their NMS or their management or software suite, all right? And you're stuck with it. So you're just stuck with that. And if you want to change vendor, you have to go off and throw all of that out and bring in the next guy who's going to do the same thing again.
But does Volta also provide for access to get services from the edge?
No, Volta is just about controlling workloads. Right now, it's only about controlling access equipment. It doesn't provide any added layer of logic or features. It really is an adaptation layer. Okay. So another reason of why really we built Volta was, there's many newer OLTs that are coming out that don't have good software that comes with it, or that allows you to control it. A couple of vendors that we know of here. And so the idea here was to build a system that allows us to kind of control all of these once and for all, rather than always having to rewrite a new piece of software. So let's talk about the high-level architecture. So this diagram, kind of the architecture of Volta. So Volta is essentially a collection of containers. Right? All of these boxes here are a Docker container. Right? The colorful ones are the ones that we built, minus maybe ONOS. I know when I say we, it's kind of awkward for me, but I guess for the Volta community, they built all the colorful ones minus ONOS, I guess. Anyway, so I'll go through these containers kind of one by one.
What's the rationale for using containers rather than like, I don't know, processes and C groups? I mean, do they all need to have their own IP addresses? Oh, okay. Well, I mean, technically that is true. So I guess the question maybe to rephrase my question, how heavyweight are these containers? Are they just processes and C groups for isolation purposes, or
they have IP addresses?
They need to have IP addresses for some reason.
They don't
They need to have separate IP addresses. I mean, like you could imagine, for example, just one container, which would have all the IP addresses that you need, right?
Yeah, sure. You could shove. So Volta, the way we deploy it, we use containers. And there's a reason for that. For scaling, HA, clustering across large systems. Right? If I want to go from one host to running Volta on 10 hosts as a cluster, right, using this kind of repeatable model, it's much easier than just having processes running on one machine.
Oh, well, I was saying that, one container, like that is your outer rectangle, that makes a lot of sense to me, right? But having all those inner rectangles seems like they may not need their own IP addresses. Maybe you want them in C groups for isolation purposes, but that's probably all you need.
I mean, you could. I mean, there's nothing that stops you from doing that. It's just what is easier to implement? What tooling do you have? And this kind of like microservice ecosystem gives you a nice framework to develop things. Okay. So
It's a trade-off in terms of resource utilization.
Sure. But I mean, as long as you're not going hardcore into the performance, we're actually pretty good with it. If you actually run Volta, very, very lightweight compared to others. So I'll go through each container, and then I'll talk about the rationale of how you would scale such a system, and what each of, like, for example, how these containers help us scale, help us kind of scale across these large systems. And I think it'll become pretty apparent as I'm talking about these things. So first, let's start from the northbound. Well, you all know ONOS, obviously. That's Chameleon, right? Chameleon is just a container that takes in a gRPC proto and converts it to REST, right? So it auto-generates our REST APR and our Swagger documentation is all auto-generated from our proto spec. So if you modify the proto spec, you get a new REST API and a new Swagger. You don't have to, you don't need to go in and modify this by hand. It's done automatic, auto-generated.
So is it taking, sorry, go ahead.
Go ahead, one of you.
I mean, the Chameleon, so that is something your team wrote, or that is a tool that is off the shelf?
No, we built parts of it.
So it's not an off the shelf tool.
So we based ourselves on there was an existing thing that.
Like gRPC Web, there's a project that does this, right?
Yeah, there was something that already did most of it. We augmented it a little bit because we needed to like react to changes and a few things. This was early on, so my memory is a bit crazy there. So that's one thing. OF agent, I mean, by its name, it's an OpenFlow agent, right? It exposes OpenFlow. But again, same thing, right? It takes in a gRPC set and generates all the OpenFlow bindings. Right? So if you modify your gRPC set, you get a new OF agent and a new support for OpenFlow messages that are mapped into this. So this is kind of cool, right? So you are always auto-generating. Finally, because of who was interested in this, we had to do netconf. We didn't particularly want to, but we had to. And so netconf, the way netconf, we took a server, an existing server off the shelf netconf server, and what we do is from gRPC we auto-generate our Yang models. Okay, so all the Yang models are auto-generated, just like OpenFlow, just like REST.
I really like this because it's the opposite of what so many people want to do, but you realize that Yang is low on the food chain, or I mean, low on the food chain, but further down the line in terms of priorities, probably not the thing you want to do.
So the cool thing about this is you modify your authoritative API with gRPC. Everything is protos, whether it's internally, whether it's externally, it's all protos. And once you modify it, you get the new thing, you get the new stuff auto-generated.
So I guess my question for you is if Nonos has like a gRPC or prototype southbound, does it, and a netconf southbound, which one, and maybe even REST, which one is used for someone with gRPC? Well, I mean southbound. I was talking to Volta.
Oh,
right. So presumably
they're all.
I mean, I don't see a path directly to gRPC from Onos to Volta, but presumably you could, right, if you wanted to.
So again,
are you planning on reusing the existing netconf southbound to talk to it for configuration purposes?
So you could, right? So what I'm saying here is right now we focus on exposing these three northbounds, but they're actually all equivalent. OpenFlow is not functionally equivalent to say REST. OpenFlow you cannot express add a device, create this new logical device. Okay. But what I'm saying is that like if you take netconf or REST or for configuration, let's say, they are functionally equivalent. You could do the same thing in netconf or rather through Yang in netconf that you could do through REST. Same thing.
I guess if you wanted to be crazy, you could also generate OpenFlow extensions too.
Yeah, you could.
Except there's that bootstrapping problem.
Yeah. So you could do a lot of things. I mean, we decided to keep it rather simple.
Yeah.
Let's not like go crazy here. But anyway, all right. So then we have these guys all talk gRPC. So we are all familiar with gRPC here. gRPC server client kind of relationship. So keep that in mind as we're moving along, right?
So with like the OpenFlow agent, so obviously when your model changes, the gRPC stubs change, right? And then there's some piece of this which does your mappings from your gRPC stubs to your OpenFlow 1.3. How much, can you sort of talk to what portion of the agent is auto-generated, what portion of it?
So we have basically
how did that mapping take place?
Basically what we have here is a gRPC for the OpenFlow case. We have a gRPC proto that basically looks like OpenFlow. It's not quite OpenFlow, but it looks like OpenFlow. And from that proto, we auto-generate all the bindings here.
Okay.
So the OpenFlow case is a little more contrived than the other ones. The other ones are kind of general purpose. The OpenFlow one obviously can't be general purpose because OpenFlow is all about forward. It's not about configuration. It's not about like open-ended stuff, right? so keep in mind that this is all gRPC, okay? So all these containers are talking via gRPC, so just keep that in mind as we're moving along. This is kind of a fundamental concept of microservices, of how you deploy these.
Anytime you change your protobuf spec, the API gets also generated. You have in place or in planning any versioning of the API?
No. So for REST, we're thinking of always like incrementing the version number, just like V1, V2, V3. We didn't really like for an initial implementation of Volta, we didn't really we talked about it for about half an hour, and then we're like, you know what, okay, let's move on to something more interesting, and we'll think about it later when we get into this problem of like how do you evolve and like how do you upgrade Volta, making sure that nobody gets confused as we move on. Right now, it's like the version stays the same. I think it stays all at V1 right now. But and really, what you should do is every time the model changes, you increment the version number. I don't know, whatever. I mean,
It's supposed to be like one advantage of like gRPC, right? You can have backward compatible.
yeah, which is the problem with it. But there's also like maybe I should speak a bit more to this. The protofile here for like the REST part has uses an extension of protofile where you basically it looks like comments to the gRPC to the protofile, where you basically like are talking, you indicate to this process here, whether it's a post, whether it's a get, because you can't express these things in gRPC in proto, so they kind of annotate it on top of it. There's a little bit more work that has to be done, but hey.
This is the same stuff that the gRPC Gateway project uses? Same annotations that Gateway?
Yeah, I think so.
It's like Google API.
Yeah, exactly. Yeah.
Okay. So you're basically using the protalk generator that Gateway provides to do the sort of model support, and then you just wrote your own implementation of the web server machine?
Yeah, it's all, yes, I believe it's all based on client. It's all Python, right? So it's all client.
So your objective with Chameleon is not to provide a dual-pronged gRPC and REST API REST element?
Only REST.
Okay. Because the idea with the Gateway project is to have fallback to, if you have HTTP 1.1 or 1.0, you fall back to REST, and if you can talk gRPC then.
Here, we focused on like each container providing one function, so we didn't want like Chameleon to expose both gRPC and REST. Okay, you're doing REST, you expose REST. That's it.
And if you look at, I think there's sort of different use cases, right? Which is that Google's use case is a web app that's connected to a server, and it doesn't, and either one can sort of change kind of independently. And whereas others or whoever, they're sort of willing to, they can sort of, if Volta provides both, they can take this one and it's all that complicated. They're not stuck. They're not trying to ship it into sort of web app.
No, I think that
it's
we can.
Let's move on because I mean this is fun, but it's the least interesting.
I have one quick question here. How does OpenFlow agent know where ONOS is?
Hold on, we'll get there.
Okay.
Okay. So that's what I was saying. Keep in mind that all these guys are talking gRPC. Same thing here. These guys are talking. They need basically to discover each other. They're all containers. They all have IP addresses. They're all running in their own process space. They need to find each other, right? So I'll get that. Let me just walk through this entire thing. I'll tell you exactly how this happens. This is a big fundamental aspect of microservices. If you can't do that, you're never gonna make it. Right?
So we are currently stopping that container and manually start OpenFlow agent as a process pointing towards the ONOS.
Yeah, that's not the right way. But anyway, we will talk about this. Hold on. So anyway, so you have Volta, you have this gRPC API, and Volta, we'll get into the nitty-gritty of Volta in a second. So Volta, I mean, maybe I should just say, I'll talk about it later. Volta, just think about Volta receives gRPC calls from the north. It takes those gRPC calls and does something to a driver that ultimately does something to an OLT. Okay, for now, that's enough for now. It also collects KPIs, alarms, events from devices, or rather from drivers, and publishes them to Kafka. And it stops there. Volta doesn't do any alarm processing, any root cause analysis, any alarm correlation, none of that. It doesn't do any plotting of metrics, nothing. It publishes them to a message bus, and that's it. and that its job is done. Actually, all API calls in Volta, if you will, like all inter-service calls in Volta go through a pub subsystem. So they all are published to pub. Whoever wants to is interested by a call can listen to it.
So presumably the netcon daemon would
No.
care.
No. The netcon, you mean this dude here?
Well, I guess the question is like, how are the up calls? Where do the up calls come from? And how are they?
Of calls.
Yeah, forwarding notifications. Like that.
So notifications through netconf are not currently supported, as far as I know. That might have been added, but what I'm saying is that all alarms get published to Kafka. Now, from Kafka, we'll talk about what happens from Kafka. Kafka is just like a distributed message bus, right? Right?
I guess I'm confused. How are alarms normally handled in how are they propagated upward? Through netcon or netcon.
Not controls alarm.
No, I mean, in ONOS, alarms are, maybe you can.
You don't have like faults.
Yeah.
We have a fault management system, but it's not unfinished.
So here, keep it, just don't focus on how are these alarms. These alarms are getting to Volta through a device-specific mechanism. That could be an open mechanism like exchanging JSON information between the physical device of Volta, or something like that.
I don't care actually. What I'm interested in is how they're propagated up.
To ONOS, right now they're not propagated to ONOS, right? They get propagated to Kafka. If ONOS wants to listen to Kafka and get events and alarms, it can. But that's it. They're not propagated to ONOS directly.
So there's a different southbound talk to Kafka.
Yeah, I mean Kafka is just a message bus. You connect it. Right? It's just a message bus. You listen to it.
Okay, so that was the missing box between us and the missing box, I guess.
But well, we don't
Kafka southbound.
and we don't actually have.
Yeah.
We don't actually do this right now.
Okay. Hello. Hi, everyone. Sorry. Can I just say something? There's a number of people online, and this talk is coming through. I mean, can we let Ali proceed a little bit before constantly interrupting him with questions? Maybe we can have a question answer session a little later on.
All right, fair enough.
Just it's not coming through as a very good talk for the folks online, because sometimes it's hard to hear the questions and there's continuous discussions. So if you just get through a little bit, then maybe we can come back to the questions.
Sure. All right.
Thank you.
So no more questions until the end. So basically, KPIs, events, and alarms are published to Kafka. That's where Volta stops, right? Volta doesn't process alarms, no alarm correlation, no nothing, right? It just publishes the alarms and says, "Have a good day, I'm done." Okay. Continuing down that path, we wrote a very, very tiny container that's about 10 lines of Python or 5 lines of Python. Basically reads the Kafka bus for KPIs and publishes them to Grafana, right? And displays them in Grafana, and the user can log into Grafana and create his own plots, and he can have nice plots of the performance metrics that exist in the system. The reason to show an example of why Volta itself doesn't do stats, doesn't process alarms, because there exist open source solutions that do it already for you much better than you would ever do it. Right? So Grafana is actually freaking beautiful, and the UI is excellent. Right? So it does it all for you. We have alarm correlation systems that also do the alarm correlation for us. We'll leave it that way. So for logs, we took an approach of kind of like structured logging. Everything goes into fluentd and is logged in a centralized location. Allows you to search for it via Elk and Elasticsearch, kind of the usual stuff you'd expect for logging. And finally, the coordination in Volta goes through console and registry. So there was a question earlier about how do these containers, how do we know where ON.Ops is? How does OF agent know where ON.Ops is? How does OF agent know where Volta is, or netconf know where Volta is, or Chameleon know where Volta is? How do these things know about each other? How can they find each other? Because you're not going to tell Chameleon the IP address of Volta is whatever it is. You're not going to hard code that in the code. That's silly, right? Or you're not going to pass it as a parameter every time you start it. That's silly, right? It doesn't work like that. How can I do this? So what happens is there's a container called registrator. It listens to the Docker API, right? So whenever a container is started, stopped, there's a whole suite of events, removed, deleted, whatever. All these are events. So when a container is started, registrator notices, hey, this new container started. It has, in its part of its definition, it has a set of services. These services are, for example, for the Volta container, it says there's a gRPC service and there is a web server. There's actually two services exposed by Volta. One is a web server, and the other one is gRPC. This information of where these services are running, the IP address, endport, and other metadata, and that metadata can be arbitrary, whatever you want, are entered in console. Console is also a key value store, so you store it in console. Same thing for all these other containers. Chameleon, OF agent, netconf, they all start up and register their services, well, get their services registered via registrator into console.
Like something like multicast DNS or...
Well, no, not really. No. So basically, this guy just listens to the Docker API, all right, and registers them, all right, and puts them into console. So then, when Chameleon comes up, it asks. So, well, maybe before I continue, console acts as a DNS server, and as well as acts as a DNS server, as well as a standard key value store with a nice API. So whenever these containers start, they ask console, or via DNS, ask them, hey, where is the service called Volta-gRPC? So if you look at the code in Volta, we say, the code that's in Chameleon, we say Volta endpoint or gRPC endpoint equal at Volta-gRPC. All right, and just that at indicates that, hey, make a request to console to get the IP address endport, and it gets it and it connects it. This is how this all happens. Now you can go even further with this paradigm. This gets a bit kind of like unbelievably amazing. So not only can you register IP addresses and ports, that's kind of wordy, pretty cool, but that's the tip of the iceberg. What you can do is register a whole bunch of metadata. All right. So Volta isn't designed to run, isn't supposed to run as a single instance. There's supposed to be a whole bunch of them running, right? And you want to put these, at least from the northbound perspective, you want to put these behind a load balancer. All right. So if you were to put this behind a load balancer and you have 15 or 200 instances of Volta, or this, right? And you have 200 instances of Chameleon, OF agent, netconf, and Volta. You want to put this behind a load balancer. You need to configure the load balancer about these 200 instances. How do you do that? You're not going to, like, every time you add a new instance of Volta, you're not going to go into the load balancer and reconfigure it. Crazy. So what happens is every time this guy registers a new set of this pod, of these 4 containers, registers all of these, it goes off and generates a new load balancer config. And load balancer is Nginx, right? So it regenerates a new set of configuration for that and reloads the Nginx container, thereby reloading the load balancer, and you automatically have scale across your entire system. And one request to a load balancer will be load balanced across all your instances. That makes sense? I don't know if I explained that very clearly.
So what is something saying? Like Chameleon saying,
It gets auto restarted.
who does that?
The Docker agent. So the Docker agent. So maybe I should talk about this. So when you fire up Volta as a whole, right, as all these containers, sometimes what will happen is Chameleon will say, give me Volta's gRPC interface. And console says, I don't know what you're talking about. I've never seen a Volta gRPC interface because it hasn't come up yet. So what Chameleon will do is essentially commit suicide. It'll just kill itself. And the Docker agent will see that, hey, this container died, and it's not supposed to be stopped unless a human has told it to stop. So it will restart itself and try again. Restart itself and try again. Restart itself and try again until it can connect to Volta. So it'll keep on going. So you kind of always converge to a steady state where everything is connected to each other and talking to each other.
So when you're explaining the load balancer, you have,
One question.
I guess I'm asking for clarification. Whatever. Go.
So, well, let me just open it up now before we move into the internals of Volta. So go for it.
So, are you saying that when you bring up a pod of these 4 containers, they're supposed to communicate with the specific pod of containers that are coming up, and console somehow knows what sort of is defining a pod? Or is it possible that Chameleon can talk to any of the Volta instances?
So that's a really good question. So we have a notion of a pod. One container that I'm not showing here because we're not using it yet, but it's completely functional, is a container called Podder. And what Podder does is you only ever ignite a Volta container, right? And then Podder says, oh, there's a Volta container. There's a Volta container. This Volta container needs company, and this company is Chameleon, OFH, and Intercom. Right? And so it'll start as a pod, as a unit, right? Because then you want to stamp those out as you go along. And the same process occurs internally, right? They find each other because they're running like in the same Docker network. There's a whole bunch of options that you can do. You can create a whole bunch of like side networks, so you can isolate every one completely.
So each of these 4 containers exists in like a pseudo subnet or side network?
Yeah, they're all connected to the same network for each thing.
But there's some metadata that explains to them that they should be communicating with one another.
Yeah.
And then the load balancing that you're referring to is load balancing on the Chameleon side?
On the Chameleon
or any of those ports?
Yeah. So it does it, and it auto-generates. This configuration is auto-generated. So you add a new instance, it triggers, it gets registered into console. Console says, whoa, there's a new set. It runs this process called console template, and it generates the new configuration file for Nginx. And the Nginx configuration lists all the instances, plus the new one, and reloads the Nginx container. You're done. Right? You have to do nothing, right? Once you've put this in place, you just add new instances and it goes off on its own.
One quick question. So this whole assembly is running on its own network.
Internally to the server.
So if you were to replicate this, that would have its own network.
It doesn't have to. You can put it in.
No, that's fine. That's fine.
But yes, I mean, I probably would to some extent if you want to keep. It depends how. These are all trade-offs, right? Like how much fine grain, like how much isolation do you want from each Volta instance? Volta.
I think it's actually a good thing. I was just simply asking for.
Yeah. I mean, but yeah, there's trade-offs, I think.
How do the white containers get started? Are they just kind of?
They're part of the compose file, actually.
Okay.
Yeah, they're part of the compose file.
But your Volta pod is the colored ones, right?
Yeah.
That's about us. And then the other stuff is kind of external infrastructure that you're relying on.
I mean, yeah, I guess it's kind of confusing, but this was the point here was to show that the white ones are things that we downloaded and used wholesale, right? We're not changing them in any way. And the colored ones are the ones we wrote.
What's the mapping? Like how many of these are shared versus how many of them are unique for Volta?
Oh, so well, that's a kind of difficult question. You get a fluency per server that you're running on. Okay. You'd have one per server, but it's a cluster, right? So you talk to one console or the other console equivalent, because they work as a scalable, highly available cluster. It's essentially, think of console as two things first: key value store, strongly consistent, right, and a DNS server. kind of a weird combination, but it turns out to be unbelievably powerful.
Yeah, it sounds like the answer is that some of these are replicated per hardware server, and some of them have a single logical.
That's what I'm asking.
Some of them have a single logical.
Yeah.
What do you use Zookeeper for?
Zookeeper, we don't use Zookeeper directly. It's a dependency of, I think, of console, because console needs to elect a leader, and we use Zookeeper for that. That's one of the drawbacks of consoles, if I remember correctly. It's a drawback of console that you have to rely on Zookeeper.
Yeah, it kind of reminds me of
Okay. Anything else? No. Okay. Let's move on to. It gets a little complicated. Well, there'll be a bigger version of this. Spare your eyes. So the Volta containers, as we said, they all communicate over gRPC. So these guys all talk over gRPC. It's kind of the main, like one of the bigger criticisms of microservices is you need some kind of RPC between your processes, right? And people often say like, oh, that overhead is too big, but it's really not that huge, frankly. Like I said,
the worst overhead is having all these containers. That's the big one.
That's very, I don't know. So this container publishes events to Kafka and persists its data in the console. So that's so for example, kind of data that we would store in console is so the point of Volta was to expose a network as a switch, access network as a switch. That switch can contain many pawn networks, all right? Many OLTs, many ONUs, right? And so one logical switch can be made up of, say, I don't know, 100 OLTs. That mapping and how it's mapped is stored in console, and then we can shift that load around by assigning OLTs to a new logical device or moving them around for load and whatever. We also use console for service discovery. In Volta, within the blue container now, we have a gRPC server that we're talking about. There's also a REST server, kind of a web server, and I forgot to talk about that. But one other thing that we do is every single container kind of has a little web server and it reports its health, right? And console, when you register into console and you register your service with one that's just called health, console triggers a process where it checks that container periodically for its state. Right? It'll just keep on asking like, are you okay? You okay? You okay? And then it just reports it out. That's all you need that thing for. I'll walk through this in a second. At the bottom here we have adapters, right? So these are all the stuff that talks to containers. So we have a simulated set of adapters, OLT and ONU. We have a microsemi OLT and ONU, Maple OLT, Broadcom ONU, Tibit OLT, Tibit ONU, and then we have an emulator and a gRPC, shim, which is equivalent. Okay. So you might ask, why is the OLT adapter and the ONU adapter two separate adapters rather than just one adapter for the particular vendor? And the reason is you can achieve interoperability. So typically how this works is the OLT you speak over, you have an API to talk to it. And that API may be proprietary, may be open, doesn't really matter. But then when you end up configuring the ONUs, you configure the ONUs over OMCI. And this OMCI is roughly standard. Okay? So what you can do is you can plug a Broadcom ONU to say a Tibit OLT, and you can configure provision a Tibit OLT as you usually would, and then you can tell the Tibit OLT it will connect the Tibit OLT to the ONU, and you will see the ONU register, and it will register with a vendor ID. The using the OMCI that's specific, or rather the order of messages that is specific to the Broadcom ONU, you can now activate that ONU. So you have interoperability that comes through that mechanism without adding any extra code. Okay, you didn't have to do anything more. It's just, that's how it works. You plug a Broadcom ONU to this OLT, it registers, the vendor string comes to you, you use that vendor string to activate the adapter for the ONU that you saw, and then you just talk to it like any other adapter, as if it was connected to its, you know, to the OLT of its own brand. That's kind of cool. So now you have this interop between vendors, which so far wasn't quite all that possible. Right? So vendors had to specifically implement in their OLT software, in their OLT firmware, I guess, support for other vendors. And here we can just do it kind of for free, and we've demonstrated that before.
But it depends on you writing this vendor-specific driver, right?
Well, I mean, hopefully vendors. Well, right now, vendors are writing them right now.
Who writes that adapter at the bottom? I guess that's what I meant by those two drivers. I guess you call them adapters, yeah. So is there a piece of software that you have to write that the vendor doesn't supply, or?
No. So right now, the one we have here, these two, are supplied by Tibet. Tibet is writing these guys. For the microsemi, I'm writing it, but that's a kind of a special case. For Maple and the Broadcom ONU, we have support from Broadcom. And most of the work is being done by Sienna.
But it is new work. Yeah.
Sure, of course. What else? Yeah, what else?
Ali, is the Broadcom whatever OLT driver or whatever you call that has come back in open source, or that is?
Yeah, it is back in open source, so there's a small little twist to it. Sienna made the decision not to write their Broadcom, so the Maple OLT adapter doesn't talk to the Broadcom SDK. It talks an RPC to an agent that's running on the Broadcom device. So as long as you don't have that agent on your device, you can't use that guy. Right? They made that decision for, I'm not quite sure why. It might be legal reasons, because if they were to talk Broadcom SDK from Volta, they might be exposing parts of the Broadcom SDK that they're not allowed to expose. I don't know.
And that agent comes from Broadcom or from
Sienna.
Oh, and that agent is not in open source?
So I had a while back commitment from them that they would open source it, and changes happened in Sienna, and now I don't know who to ask anymore.
That agent is statically linked with Broadcom BAL API. BAL SDK.
No, it's not on the BAL API. The pawn agent is built to the Broadcom SDK, not the BAL API. I know that question, but the point is that they have said that they would open source it, willing to open source it at the time. This was a couple months ago, but then I guess the management changed. Right, and so now I don't know. Maybe we could ask them again.
Because without that agent, this is not usable with Broadcom, right?
No.
The whole Volta is not usable.
Not now, but there are other people stepping up to build an adapter for Volta for Broadcom kind of native.
That is all redoing.
This is something we have to discuss, because there are two versions of agent now. Radisys has developed one agent, and Sienna has developed one agent. So nobody has contributed that to the community yet. So we are demonstrating with Radisys agent, Sienna.
I guess
Maybe that's the site.
Yeah, I guess to kind of like there are many more agents out there for Volta that have been built by the community, well, by vendors that are not in open source. Okay?
Yeah, but I think if it is like a Nokia specific box or something, they don't open source. Ictron specific one, that I don't care as much, but Broadcom or Celestica one being usable by the community is very important. Anyway.
Yeah, I mean, I agree, and I think it's a shame. It's a shame that they took that path, but it's a decision that they made. Like, I mean, what are we to do, right? So anyway, so let's go through kind of like how all these components, like how does this kind of all work together? So from Volta, you get some REST call, whatever that REST call is. Add an OLT, add a flow to an OLT, do whatever, right? Add some forwarding to the OLT, do whatever, right? It doesn't really matter. It hits Chameleon. Chameleon forwards that request through gRPC to Volta, and this then goes to a global handler. The global handler does what you would expect. It says, is this for a device that is under my control or not? If it is, great. It dispatches it to a local handler. If it's not, it forwards it to its peer who is responsible for it. And the way to find out for who it is, you go to console, you ask console, you get the response, and you move on. Okay? And so this gets dispatched eventually to a local handler, and then hits our configuration store. Our configuration store looks essentially like a Git repo, except it's not a Git repo, but it looks like it. It has many revisions, and these revisions advance through time, and you can roll back to any of them at any point. It's backed by console. This then gets passed to the device agents, and that finds which adapter is responsible for that device. In this case, it was the microsemi OLT. It gets passed to the microsemi OLT. The microsemi OLT does what it has to do, whether it has to talk to the ONU or configure the OLT or provision the OLT. That's essentially all there is to it. There's not very much. There's not very much to this. It's very straightforward. It's by design that it's straightforward because it's supposed to be an agent for a device and not a operating system or something else. Okay, to this point. Okay. Let me go to my next slide and then I'll be done so we can just have questions after this. So right now we are able to provision OLTs and ONUs. We can provision them for unicast, multicast. We can do authentication, install DHCP rules, and they can forward all that traffic. We've shown it on multiple hardware. We've shown it on Broadcom, kind of Broadcom, I guess, and Tibit. And then we have a simulated and an emulated devices that are used for test and scale test and stress testing. That's why it's shipped with it. So you can, if you were to download Volta today, there's a manual inside. That manual, you take that manual, tells you how to run the simulated OLT, and explains it to you, and you can run it. Also, maybe I should say that all the documentation is inside the repo under a Git book. Right? So you just go to, get the code, go to docs, go to manual, docs/manual, and you just say make serve, and you get a web page with all the documentation that we have. And then, as you've seen, there's an OpenFlow REST, Netconf, and gRPC northbound interface. So with that, that's kind of like what I have. Let's have some questions.
When you make change to previous slides, when you have drivers, etc., how do you know that change happened and in other words, can you get the state of what has been provisioned from the
Say again.
state information, for example? How do you know what is already there, right? What's already changed in configuration?
What's already, you can read it. I mean, it's
Can you cut which the previous slide? How would you? How would you read, for example, what the provision to Microservices?
But before it gets provisioned, the configuration gets entered. Right, so it's stored. Okay, the specifics of how it was done here are not stored, but what was done is here. You can read that at any
So
moment.
there's no synchronization issue about this thing. What's in the configuration file versus what's actually.
There could be a time where they're out of sync. For example, there's a power cut or something bad happens, but then the authority is whatever is in there.
Can we reconfigure the file?
Do you, like for the overflow reporting tools, do they also version the Netconf store as well?
Again,
So like, forwarding messages.
Yes.
Etc.
they're all stored in the store, all the flows. So maybe let me talk about that a little bit because so maybe So when you provision a flow onto a PON network, right? Some of the functionality of that flow, say for example the adding of a VLAN tag, gets done at the ONU, and then the OLT just forwards the packet or something, or adds another VLAN tag. So you add two VLAN tags. One VLAN tag is added at the ONU, the other one is added at the OLT. And these operations occur either on the ONU or the OLT, depending on the capabilities of the ONU and the OLT. So when you push a flow into Volta, it gets into the core of Volta, and the flow gets decomposed into a part for the ONU, a part for the OLT.
And that's standard for all vendors, or is that?
Right now, it's standard for all vendors, but there's something we have it in place where it's basically data driven, where you basically like kind of, let's say, we have two options. We can either walk a tree and say like kind of ask the devices what do you do, what do you not do, and based on that do that decomposition, but it's kind of a difficult algorithm. The other option is data driven, where you say a Celestica OLT with a Broadcom ONU. This is the decomposition you should do. This is the type of decomposition. It's kind of a bit of an annoying part, but you have to do a decomposition so that both devices get their respective partitions.
Basically, you're saying you have all the combinations of ONU and OLT, and for each combination you say how to do decomposition.
Eventually, right now right now the decomposition is common for everybody, because we know, I mean, for access networks, the ones we're actually deploying right now, we only have a handful of rules. So we know that decomposition is rather standard. So we've applied that like standard decomposition for everybody. But now, in the fullness of time, where you start doing maybe more involved things, then you'll have to maybe rethink this. And these are the solutions that we put into that. Is it data driven, or you can walk essentially a tree of your OLT. And the tree is actually stored. The tree is actually stored in here. This is how these OLTs and ONUs are connected. It's actually stored, so you can easily walk it and ask figure out what their capabilities are, and then on your way back up the tree, you just filter it out and you get the results. But it's
Because the thing I was saying, on top of Volta, the northbound, is the gRPC interface somehow standard, or I mean, you have to. So how do you? So is there any standard API, or everything is automatic? I mean, generated. If you go to one of your earlier pictures where you were showing the overall, yeah, this one, right? So on top of Volta, the gRPC, is that somehow API? So how is that? So as you add either more devices or as Volta evolves, the API is evolving?
No.
Then? Okay.
So if you add more functionality to Volta, then that API evolves. Okay. If I add support for another device, the API does not evolve.
Hopefully it doesn't evolve.
Well, unless there's something like that could cause. I mean, unless there's something earth-shattering, right? That the device somehow can grow arms. Yeah, maybe, right?
Could it be that there's differentiation among the devices, and that devices like add new features that you then want to expose?
So I would say
northbound.
Yeah, I mean maybe
Usually that's how vendors work. They always come out with some new feature that now they want to write an app that uses it, right? So you need to be able to call all the way down.
But then that.
So.
But assuming you're right that it is not changing, but then isn't that the API that is kind of standard over Volta, and that?
Yes, yeah. I mean, it is the authoritative API of Volta.
Right. Okay.
Right.
And everything else is derived, right, from that.
Yeah.
And is there any either discussion, debate among all different device providers to say, hey, this API is not sufficient, it doesn't let me take advantage of my features?
We've had that conversation, but in a different way. We've had that conversation where no one has come and said this API is not sufficient. People have said you should standardize it. You should go to standards bodies and make it standard. And we were like, no, we're not doing that, because we're under tight schedules to make that, and we don't want to go off and standardize these APIs just yet. And honestly, we probably the northbound northbound API, I don't think will change very much. I think the southbound API between the Volta core, like here, this API here, this API between the Volta core and the adapters has been changing quite a lot.
Because
we took it, we were too simple in the beginning. We took it too easy in the beginning, and then we realized, like, oh, I need this, oh, I need that, oh, I need to be able to add this. But now, I think over the past 2 months, it hasn't changed.
But it's also not, it hasn't changed, but it's also not common across all of these adapters, right? There are specific things for specific adapters and other things for other adapters. You haven't achieved a common API across all adapters,
No,
basically, right?
The same API for all the adapters.
Okay.
But then how do you, are these devices that similar?
They're not the same. It's all access.
Okay.
There's really nothing to it, right? Like, it's a PON network. The specifics are in the technology, right? So if you have NG-PON2, I think, I always get it confused whether it's NG-PON or XGS-PON.
XGS-PON, right? That is coming, right?
Yeah, it's coming as like
Even Flow and the regular GPON have everything common?
I mean, ultimately, the higher order function, right? Is take packets from there, put them there, right?
Seriously, that's been described as networking, right?
Yeah, but hold on.
Hold on. It shouldn't be rocket science, but it is for some reason.
It's not, right? And all it does is take packets from here, put them there. Now, how you do it, right? Is the communication between the OLT, the ONU, OMCI, EPON, DOCSIS, not DOCSIS, there's another one, DPoE, or some other crazy thing, right? Or how many wavelengths do you multiplex on the same, I don't know, fiber? Who the hell cares? Like, frankly, who the hell cares? Like, as long as your adapter does it and does it correctly, do you care from your management layer, from ON.Lab there? Do you care whether the traffic for your subscriber who lives in San Francisco has the blue wavelength and the other one who lives in, I don't know, in southern San Francisco has the red wavelength? I don't care.
Well, I think we would like the world to be that way. If the device vendors and so on are
so honestly, so
that's
far,
great, right?
So far, we haven't seen any reason to all the same. Actually, the funny thing is, right? So I've been reverse engineering the microsemi code to be able to write this, right? And then I looked at the Tibet code, right? The Tibet to control Tibet. The funny thing is that they're the same. Like, it basically looks the same. It's just like in the microsemi, it's a bit more spelled out because it's a packet per packet protocol where I send like one message, I get a response. And the Tibet is much more like API focused. We send an API. It was maybe a legacy vendor. So basically, but if you look at the overall high level of what these things do, identical. It's identical, even though the communication between a Tibet OLT and a Tibet OLU uses, I think, EPON, if I'm not wrong. It's like a different type of, is it EPON or DPoE? I can't remember. Anyway, it uses a different mechanism, but ultimately it's the same thing. The nitty-gritty is like, do I instantiate a T-cons before I have a gem port? But who cares? I mean, like, no one cares about these.
And similarly, you're saying you can create the Yang model for different devices, and you don't have to take into account anything specific about that device.
So, but this is where it gets like political, right? Because people have been wanting us to rather than generating our own Yang models, right? Wanting us to take VBS Yang models and using those Yang models as the Yang models for the netcom parts of Volta.
Yeah, but right now you're generating the same Yang model for all the devices, right?
Because again, it's not the mistake that I don't know how to explain it. The mistake that you're making is you're thinking this is a Yang model for a device. It's not a Yang model for a device. It's a Yang model for virtual device, right? So all devices that are under Volta's control are Volta devices from now on. Right? They're not Tibet, they're not Microsemis, they're not Broadcoms, they're not Nokia, they're not whoever. They're Volta devices.
Everything is common denominator.
Everything is Volta now. We have taken over the world. We own it. It's all ours.
And in that Volta thing, again, there is no device-specific thing that you can.
So there are extensions which we can transfer across.
Oh, you can.
We haven't. Have we have an example of that? I don't think we do right now. We have a mechanism to transport extension, but we kind of kept it kind of narrow and very small by design. But by design because we had friendly vendors who wanted to work with us. Now the day will get ugly when vendors will come along and try to break this model, and they will. Right? But ultimately, I think the amount of traction that we've gotten over the past few months for a piece of code that is September. That's 3 months, 6 months old, right? For the amount of traction that it's gotten, it's going to be hard, right? It's going to be hard to. I mean, people can always deal with it. Right? Someone will find a way. Someone will find something else. They'll invent some other random code. They're like, oh no, you need netconf 2 and yang 3, and it will, you need this. If you don't have this, you'll never be able to do it. But it's not true. I mean, so far we haven't run into any problem. And actually, when we've gone to a service provider, I mean, you all know who the service provider is, but I can't say who's being recorded. And the speed at which we find a problem, because this is nascent software, find a problem, fix it. The speed, their minds were blown, right? The fact that, like, in the first iteration of the software, we can show interop between two hardwares, right? Mind's blown, right? So these things are working. These things are freaking people out. It's great.
So, Ali?
Yeah.
So you're saying you have a common southbound API across, from the core to the adapters across Microservices, Maple, and Tibbet?
Yeah.
Okay.
That wasn't a question?
Yeah, that was it. I was just trying to see because some time back it was an API for I think just one of them. I think the Tibbet one, and then you were able to evolve that API to work across Maple and Microsemi.
I guess at the time maybe I wasn't clear. At the time, possibly, and I'm not sure when this conversation dated from, but I guess at the time we had only implemented the API for Tibbet, but not for anybody else. Now
Right.
we've implemented for that Maple, for the Microsemi, and it's working. I mean, it's working. I mean, like for the Microsemi, it's not complete, but I can now take the Microsemi, discover an ONU, provision the OLT and the ONU, and I can install one flow. Pretty good.
It is working for Calyx also. Calyx hasn't contributed the driver back to the community yet.
But it's working for them. I know that.
Yeah, we are testing it in Calyx lab as we speak.
Yeah. And I know that, and that's what I'm saying. There's another vendor that's also this model is working.
So they use different interface though. Calyx is using netconf interface to configure their OLT. .com uses their BAL API that translates to some special.
That's the part. So what he's saying is Calyx from the adapter to the physical device, they speak netconf.
Yeah, but that doesn't matter, right? I mean, what I'm asking is between your core and adapter, is the API sort of common between all of these, right?
It's completely
So
common.
that's the one that people are asking you to standardize?
No.
Yeah. That's the one people have wanted us to, rather than writing code and making all this work, go and standardize it. Come on.
Yeah, it's backwards, right? You want to write it and get it working, and then once you works, I mean, it's the standard, what do we call it, software-based standards, right?
So where is the documentation for this API? Is that under also your, what did you say it was?
No, we don't. I don't think there is.
Because there's this guy online that keeps asking the question, where is all the documentation
So
for
if you go to, I mean, right now the documentation is the code, and actually that interface is pretty well defined. It's called adapter interface. It's a Python file, and it's got comments that describe what all these APIs are supposed to do. But We have,
No, but you also said that there was some folder that you go and you do make something and it'll give you a web interface for documentation.
that's a user manual for Volta, not a developer manual.
Okay.
If you look at the code, if you look at the iAdapter interface,
Uh-huh.
iAdapter interface or iAdapter agent, I can't remember. I think it's iAdapter agent. That file is the southbound interface. It's got comments about, like, you know, it's basically like a big paragraph on top of each method call. And you know, that's the documentation we have right now. Hopefully someone will write that documentation better.
Ali, I just have a comment on your, well, I think it's a good idea overall. I have a comment on your presentation. Unfortunately, my brain was like out to lunch at the beginning of it, and since I'm not steeped in access networks, it took me a while to sort of recache all that distantly paged out information. So I think, you know, if you want to, you know, maybe everyone in the room is experts, but for more general audiences, I would find it valuable to have just an initial slide of reminding people what the access network components are and why they exist. I had to think like, oh wait, why does PON exist? Well, it exists because regular Ethernet doesn't multiplex multiple connections over a single fiber, right? That's its purpose for existence is to have a shared passive optical channel, as I understand it, right? I mean, essentially, and there are some historical reasons, like, well, PON exists because it needs to talk to ATM equipment, and EG-PON or whatever actually puts Ethernet frames and multiplexes things. But at the end of the day, all you're doing is you're multiplexing multiple virtual Ethernet fibers on a single fiber connection.
So at the start, you mentioned the possibility of extending to Ethernet devices. So what's the
A standard interface across all your devices. So imagine if you had cord and we didn't have to have this esoteric OpenFlow thing, right? We can define our own pipeline. We could, right? We can talk to the Broadcom chip and then expose whatever pipeline we want to expose. Right? Whatever is more convenient for us, whatever works for us. Right? And then rather than having that, you have this kind of like Volta architecture. And you only have, like, imagine rather than having, I have
Volta, right?
Yeah. I have OFDPA here for fabric switches. Right? I have Volta in the corner for what's it called, for PON devices or access. I have some other thing for soft switches. Right? All these things are different. Now imagine you have a control cluster, right? You have this network, which is kind of like it's kind of like a layer across your data center, which is the control infrastructure, right? And it's just Volta controlling and talking to all these devices. Right? You could have a Volta instance that controls access at the same time as controlling Ethernet, at the same time as controlling G.fast. You could shift that load across your entire cluster. It's all the same. It's all Volta. You get that unique abstraction given to you. So you kind of like have it's. I mean, it's not going to be rosy and simple, obviously, but it's going to at least you have the same infrastructure, same interfaces, same management across all your infrastructure. That's valuable to me. That thing that would make my life much easier because now, from an ON.Ops perspective, right? Talking to programming such a network that looks essentially the same no matter what it is. Kind of nice. Kind of nice.
Kind of the idea of OpenFlow 1.0. I mean, actually, the only reason you get away from that is that if you impose a standard, either big switch or whatever architecture you have on every big switch, standard pipeline or anything, or single flow table or whatever across your whole network, then sometimes you end up with not necessarily performance or resource usage or functionality that you want. I mean,
This is not tied by the size of your TCAM.
Right, but I was saying that, if you put that on an OpenFlow switch, for example, well, I mean, the sort of interesting thing is that if you had a switch, I mean, if you're using Volta as a cache for the hardware TCAM, then, you end up with things where like, well, we have a lot of cache misses, our performance goes to crap because we're going through software
relatively large tables, then they're not clean apps. So basically, what you're saying is the tables are not big enough. But in the case of Broadcom,
either they're big enough or they won't match on what you want them to match.
yeah, it won't match on, like, so you'll have like an L2 table, but it won't match on an L3 table. It makes programming it a little more complicated. But if you have something like Volta that allows it to like munge this arrangement of tables to something like convenient, you're not a victim of the hardware or the victim of what someone else has said, but you can define your own. Right? That's a pretty nice world to live in.
Yeah, but you're still going to define a different pipeline for Broadcom chips than you would back, right? You may do different things.
Maybe you would. I'm not saying that you most likely you would, but not sure you have to. If you have the flexibility, right? If you have the flexibility to do that, right? We've defined a pipeline in kind of the flow objective pipeline, and that pipeline seems to work, right? Kind of like across all the devices that we have. Right? In some ways, we transform it. Now, if you make all devices expose flow objective like pipeline, maybe it's easier. I don't know. It's worth trying, right? But you have to have something like this to do it.
But at least we can use why though, because like you say, we can't impose some of the differences inside of on-us, right? We have the flow objectives that allow us to, and it's still got some of those differences, and we have drivers and on-us, right? So what exactly is, how do you figure out which differences you want to impose in on-us and which you want to impose in Volta?
I would say you would make it simpler for us. Right now, this driver mechanism that we have is getting very, very complicated. So I'm not saying that you're going to
any more levels.
Yeah, it adds more software and more copies, basically.
I think you make your job overall simpler. I'm not saying that the problems all go away. It's just that you refactor where you solve the problem. That's all I'm saying. And I'm not even guaranteeing that it's a silver bullet. I'm just saying that, like in my opinion, I think you would gain a lot of flexibility by doing it.
So Ali, I have one more last question. Getting back to that OpenFlow agent to ONOS. How does OpenFlow agent know this is our immediate problem? So that's why.
So it's the same mechanism, right? So same mechanism I described earlier, right? So when you start the ONOS container, right? Assuming you're running ONOS.
ONOS is a container.
Right? It registers its OpenFlow service in console. Right? All you have to tell it what it is I want to know OpenFlow service.
The interesting thing to me is that
It's the same thing for everybody now.
It doesn't depend on us, which is actually quite a sort of neat feature of it, right? Which is that, it could work with or look like, or, review, whatever, as long as they have appropriate southbound to talk to, which is sort of nice. And in that case, the question is, how would they do the controller discovery? And what you seem to be saying is that they could talk to registrator and register themselves. Is that what you're saying?
Well, so I mean, this mechanism registered in console assumes that you're running in your service is running in a container, in a Docker container.
Yeah. So so the answer is you're depending on Docker.
Yeah. We're depending on Docker for a lot of things. There's a lot of functionality, which
I don't know.
I don't know. It is something we are trying. We are trying at Cali.
No, it's a logical argument.
I'm sure it is. It's still an opinion.
Well, it's not just. I have lots of other opinions, like guys. Everyone's entitled to their opinion.
You are. I didn't mean to say that you were not entitled to your opinion.
What's the next step for? I think. What's on the roadmap?
Holiday. No, the next step for Volta is so we have clustering primitives and HA and scaling primitives around. They're in the code. They need to be hardened and actually deployed. Right now we haven't gone. So we've shown that we can, stamp out multiple Voltas and they can work with each other. But now we have to work on making sure that the control works, the management works, all these things, stuff like that.
Other than HTTP, what else is maybe?
I don't know. Huh? I can tell you after, but I can't.
For recording.
Yeah. I can't say, but there's there are at least like a good handful of it. It's the future of the world.
It's not really talking, but I think it's, standardization, it's just kind of its architecture and its implementation and the way people use it.
In console, it's possible to register services that are not part of Docker. I mean, if you have one on premise in a VM and you
So yeah, but then you're relying on this kind of awkward thing. You're relying on your service coming up and registering itself. The nice thing about this Docker mechanism is that registrator. Actually, when I talked about Podder earlier, Podder does the same thing. It listens to the Docker API. It just listens to the Docker API. When it seems to come up, it looks at it and goes, oh, there are these ports. Okay, cool. And it's smart also to realize that it will only register ports and services that are exposed, meaning that they're reachable from outside. So nice. It's all very, very well thought out. I mean, like anything else, every new tool you find has its advantages and has its drawbacks. Some things piss me off about this stuff, some things I find good.
But to answer the question, as I understand it, like for OpenStack or VMs, you just say run Docker in your VMs. And for Kubernetes, you'd say, well, run Docker containers inside of Kubernetes containers.
Yeah, well, for Kubernetes, we're planning. We would like to. Kubernetes is very similar to Docker.
And I mean, all these things are Docker LXs. I mean, there are a bunch of them, right?
Yeah. So basically, like.
Even Libvirt.
Yeah. So basically, I mean, we're not saying that necessarily the way we packaged up Volta is the way we want to deploy Volta. But right now, that's what we're doing. But if you were to really deploy Volta, you want to. Okay. All right. More questions? There you go. All right, well, in that case, thanks everyone.
Yep, thank you, Ali.
Thank you.